Welcome to the debate. Our focus today is on, well, a really fascinating challenge posed by highly anomalous interstellar objects, specifically 1I Oumuamua and more recently 3I-Atlas. These are objects whose, frankly, unique characteristics just don't fit neatly into our standard astrophysical boxes. And the central question we're sort of grappling with is this. Should the combination of these persistent, unexplained anomalies, both in how they move and what they look like, should that compel the scientific community to, shift priorities, to maybe start actively searching for an artificial or technological origin, especially for these objects that hit level 4 on this new classification scale?
Right.
My position is that, well, when the natural explanations become so strained, so improbable, the technological hypothesis actually becomes arguably the strongest fit for the data we have, particularly for these level 4 cases where the stats are just off the charts.
And I suppose I'll be taking the, let's say, more conservative view here. While these anomalies are certainly dramatic, even puzzling, I believe rigorous science demands we first exhaust all possible explanations within known physics. History is littered with anomalies that turned out to have perfectly mundane, if perhaps novel, natural explanations. Think about pulsars initially being called LGMs. The burden of proof for claiming alien technology has to and should remain incredibly high.
Okay, fair enough. Let's maybe start with Oumuamua then, because it really set the stage for this whole discussion. It's non-gravitational acceleration, this tiny, constant push away from the sun that's the absolute key feature. And crucially, this push happened without any detectable cometary activity. No tail, no gas cloud. Data from the Spitzer Space Telescope pretty decisively ruled out the kind of mass loss you'd expect from, say, water ice or carbon monoxide sublimating.
Right. The lack of a coma was definitely significant.
Exactly. So it meant the push wasn't like a typical comet's rocket effect. It wasn't just stuff boiling off. Instead, the force followed a smooth inverse square law, which is, well, mathematically identical to the force exerted by solar radiation pressure, sunlight literally pushing it.
Okay.
But for radiation pressure to be strong enough to cause the observed acceleration, the object's shape had to be extreme. It needed to be exceptionally thin and wide, almost like a sail. The calculations suggested a mass per unit area or column density of only about 0.8 kilograms per square meter. Now, to give listeners a sense of that, if it were rock, it would be less than a millimeter thick. And, well, nature doesn't really seem to make macroscopic objects that flat and wide floating around in interstellar space. That geometric requirement points quite strongly, I think, towards an artificial origin, maybe a light sail.
I see the mathematical tidiness of the radiation pressure idea. I do. But I have to push back on the implication. You're asking us to accept an object with a geometry that, as you say, nature doesn't produce, essentially to avoid accepting it might be made of some material we haven't seen before or fully understood.
Well,
You're right that Oumuamua really forced astronomers to think outside the box, considering things like, those exotic hydrogen icebergs or nitrogen icebergs, or even these strange, fluffy fractal structures maybe 100 times less dense than air. But your light sail hypothesis, that's also based on pretty extreme assumptions, isn't it? It basically requires some advanced civilization to have, flooded the entire galaxy with maybe 10 to the 25th or 10 to the 26th bits of super thin debris. I mean, that's a pretty staggering thought, and we have absolutely zero independent evidence for that level of galactic engineering.
But is it more staggering than inventing entirely new types of natural objects that somehow survive interstellar journeys?
Well, let me finish this thought. I think the acceleration mystery could still lie within physics we don't fully grasp yet, or perhaps materials under conditions we haven't modeled. Even if those H2 or N2 icebergs face, quote, serious difficulties, what about sublimation of other supervolatiles we just couldn't detect? The total mass loss needed to explain the push was only about, 10% of the object's estimated mass? That's not insignificant, but maybe not catastrophic evaporation either. And if the particles coming off were larger, say, millimeter-sized dust rather than fine gas, they'd have 1,000 times less surface area for their mass, making them basically invisible to Spitzer while still providing that gentle rocket thrust.
Okay. But you're proposing a solution that requires us to essentially invent an exotic material that, 1, sublimates invisibly, 2, somehow survives potentially billions of years drifting between stars despite cosmic ray erosion, which is a huge problem for things like hydrogen ice, and 3, arrives here in such large numbers that Oumuamua isn't just a one-off fluke. Why should we prefer that frankly convoluted model over the mathematically consistent observable force of radiation pressure acting on a shape that, yes, is unusual, but physically plausible if engineered?
And about those supervolatiles, especially the hydrogen or nitrogen icebergs, the evaporation rates during interstellar travel are a major hurdle. They likely wouldn't last long enough. Plus, there's the rotation issue. If the push came from localized jets or outgassing, you'd expect that to create torques, making the object tumble or spin up erratically. But Oumuamua showed this remarkably stable, constant light curve periodicity. That implies stable rotation, which fits perfectly with the uniform, gentle push of sunlight across a surface, not the chaotic sputtering of localized jets.
I have to challenge the idea that stability automatically rules out natural explanations. Yes, the constant periodicity is interesting, but the requirement for your light sail, that extremely low column density, less than 0.8 kilograms per meter squared, that's also completely untestable without getting up close and personal with the object, which we can't do. So we're kind of using one extreme ad hoc assumption, the sail shape, to argue against another potentially extreme assumption, like invisible outgassing from a novel material.
But one aligns with known physics, the pressure of light, the other requires inventing new materials or physics.
And what about the fractal dust bunny idea? A highly porous object may be 100 times less dense than air. That's a potential natural way to get a very low average density without invoking alien engineers. Yes, there are questions about whether such a fragile structure could survive near the sun. But if we're dealing with a truly new class of object, maybe our current models of survival are just incomplete. The lack of spin-up you mentioned is tricky for standard outgassing models, I grant you. But maybe that just tells us our standard models need tweaking for these kinds of exotic objects, not that they must be artificial.
Okay, let's pivot to 3I-Atlas then, because I think here the statistical case for something non-random becomes, well, almost overwhelming. We're not just talking about one physical anomaly anymore. We're talking about a whole suite of dynamical improbabilities that, when taken together, really stretch the bounds of coincidence.
Okay. Lay out the case for Atlas.
All right. So, multiple things stand out. First, its orbit. It's retrograde, going against the flow of the planets, but its orbital plane is tilted only about 5 degrees relative to the ecliptic, the plane where the planets orbit. For a randomly arriving interstellar object, the odds of having that specific low inclination, near ecliptic but retrograde orbit are only about 0.2%. So right off the bat, statistically rare.
Rare, but not impossible.
Not impossible, no. But then add this. Its trajectory brought it remarkably close to several planets in a relatively short time frame. It made close approaches to Venus, about 0.65 AU, Mars, really close, 0.19 AU, and Jupiter, around 0.36 AU. Now, calculating the probability of that specific sequence of close planetary encounters happening just by chance for a random incoming object, the cumulative probability is estimated at a mere 0.005%.
0.005.
Yeah, that's 1 in 20,000. 1 in 20,000 odds of that trajectory synchronization happening randomly. That number alone should make us sit up and take notice.
That is a wild statistical claim. I'll give you that. And the Mars proximity is certainly notable. But, correlation isn't causation, and extreme improbability doesn't automatically equal artificial intent. A highly unusual trajectory might simply mean it belongs to a population of objects we haven't sampled well yet, maybe from a very specific, rare origin. And we have to consider the other constraints, right? Like the size paradox. If 3I-Atlas was as big as initially thought, maybe 20 kilometers, we should have seen millions of smaller ones first, according to standard population models. That suggests it's either a very rare large object, or perhaps more likely, it's actually quite small, maybe a nucleus less than 0.6 kilometers across that was just unusually active.
But the type of activity is also weird, isn't it?
Well, yes, the lack of detected cometary gas, despite having a dust tail,
is genuinely puzzling. It makes it different from, say, 2I-Borisov, which looked much more like a conventional comet. But puzzling is what drives astronomical discovery. It doesn't automatically scream technology.
Okay, I agree we shouldn't leap from puzzling straight to alien probe. But when you have a 1 in 20,000 trajectory synchronization, combined with the fact that its closest approach to the sun, its perihelion, happens in a very specific, advantageous place, well, the case demands more than just saying it's puzzling.
What's specific about the perihelion timing?
Okay, so 3I-Atlas reaches perihelion on October 29, 2025. And crucially, that point in its orbit occurs almost exactly on the opposite side of the sun from Earth at that time. Now think about spacecraft dynamics. That location is precisely optimal for performing a reverse solar Oberth maneuver.
Meaning, using the sun's gravity to decelerate efficiently?
Exactly. The Oberth effect lets you get the most bang for your buck from your engine burn when you're deep in a gravity well. If 3I-Atlas were a technological object trying to slow down, perhaps to enter orbit or stay within the inner solar system, doing that deceleration burn on the far side of the sun is not only efficient, it also keeps the maneuver maximally hidden from Earth-based telescopes. The sun itself acts as a shield. So now you have this convergence, extreme statistical improbability in the trajectory, and a key orbital event happening in a geometrically advantageous and potentially stealthy location. That, to me, pushes it way beyond simple coincidence.
That's certainly a sophisticated interpretation of the orbital mechanics, but I have to maintain that you're layering interpretations here. You're moving from statistical improbability, which is observable, to assuming operational intent, remaining hidden, decelerating efficiently, which is entirely speculative about motivation. We can't verify or falsify if an object intends to hide without, asking it.
But the physics works.
The physics might work for that scenario, but we have to guard against confirmation bias. We see something weird, we look for explanations, and sometimes the most exciting explanation seems to fit. But look at how these things often play out terrestrially. Take the U.S. government's AARO, the All-Domain Anomaly Resolution Office. Their job is literally to investigate UAPs, UFOs, whatever you want to call them. And consistently, report after report, they find no verifiable evidence of extraterrestrial technology. Most cases get resolved as mundane objects, sensor artifacts, atmospheric phenomena. Sometimes the data is just insufficient or the sensor capabilities are classified, so they can't give a full public breakdown. But the point is, unexplained very rarely, if ever, turns out to be extraterrestrial.
Look, I completely support the work AARO is doing, and I absolutely agree. Unexplained does not automatically equal alien. But the issue I see is a potential institutional bias within the broader scientific community, an ingrained assumption that the origin must be natural, even when the data screams otherwise.
You think scientists are biased against finding evidence of ET? That seems counterintuitive.
Not against finding it, perhaps, but against seriously considering it when anomalies crop up. The source material itself notes how standard classification systems can sometimes act as blinders, forcing us to cram these square pegs like Oumuamua's flatness or Atlas's trajectory into the round hole of weird comet. That's why initiatives like the Galileo Project are important. They're trying to actively search for extraterrestrial equipment near Earth, using AI to systematically sift through data and look for things that aren't birds, planes, drones, or natural objects. If something looks highly unusual, especially high up, we should investigate it seriously, not ridicule the possibility. Our approach needs to be driven by data, not by a philosophical preference for natural explanations only. We should be looking for things that look like the stuff we build and launch.
Okay, intellectual disagreement is healthy, it sharpens understanding, and I absolutely support getting more and better data. Projects like the Vera Rubin Observatory are going to be game changers for finding more ISOs, no question. But I still believe the most robust scientific progress comes from rigorously challenging anomalies within the framework of known physics. The ARO director explicitly stated they followed the science and data wherever they lead, and the scientific consensus right now, based on all available evidence, is that there's simply no credible evidence of objects operating outside known physical laws. And when you talk about SETI, the search for extraterrestrial artifacts, you run into these deep philosophical quandaries. If you start assuming, as you hinted with the Oberth maneuver, that an object might be trying to hide, well, how do you ever disprove that? It becomes an unfalsifiable hypothesis.
Shouldn't we focus our resources on transparent, high-quality data collection and let the scientific method work? Exhaust the natural explanations first, however exotic they might seem, before we jump to the ET conclusion just because the statistics are eye-popping?
But the numbers aren't just eye-popping. They are mathematically straining the conventional framework, arguably past its breaking point. For Oumuamua, the physics point strongly towards an unusual geometry, perfectly consistent with radiation pressure. For 3I-Atlas, the dynamics present a trajectory that is wildly improbable by chance and suspiciously convenient for engineered control. These objects hit level 4 on the classification scale for a reason. They represent persistent anomalies that are, at the very least, weakly consistent with technology. That warrants a dedicated investigation, maybe new missions, certainly new analytical frameworks. We should treat them not just as cosmic oddities or failed comets, but as potential opportunities. A chance we might actually find technological signatures, equipment perhaps resembling what our own civilization produces.
And I would counter that we need to maintain intellectual humility here. Yes, these objects are absolutely fascinating, and they deserve every bit of the intense scrutiny they're getting. But level 4 just signifies the start of a comprehensive investigation, not the conclusion. Confirmed technology, according to that same scale, is way up at level 8 or higher. We're nowhere near that. We keep finding examples where strange astronomical phenomena eventually get explained by conventional physics. Sometimes very exotic, newly understood physics, sure, but physics nonetheless. We have to make sure we don't let our own biases, whether that's an insistence on only natural explanations or an eagerness to find technology, color our interpretation. These objects might genuinely represent completely new types of natural material or phenomena we've never encountered before. There's still so much we don't know, and much more data needed to really settle this debate.